FastMCP 3 implements a pipeline-based transformation system where components flow through a sequence of middleware-like filters before reaching clients. This design employs the Decorator pattern to wrap component sequences, enabling progressive modification through chained transformations. We will examine how provider-level transforms are initialized and composed, with a namespace transform applying prefix-based isolation, followed by a ToolTransform that performs targeted schema modifications on the already namespaced components. The code demonstrates how these transformations stack in execution order, creating a layered processing flow where each transform operates on the output of its predecessor. From FastMCP server providers, import FastMCP provider. From FastMCP server transforms, import namespace, ToolTransform. From FastMCP tools ToolTransform, import tool, transform config. Provider equals FastMCP provider server. Provider, add transform namespace API, hash applied first. Provider add transform ToolTransform hash, sees namespace names. API verbose name, ToolTransform config name equals short. Hash flow, verbose name API verbose name, short. This code demonstrates a two-stage transformation pipeline for tool names in FastMCP 3, combining namespace prefixing with targeted renaming. The namespace transform first applies an API prefix to all component names, creating a scoped naming convention that prevents collisions when composing multiple servers. This is followed by a ToolTransform that selectively renames specific tools using ToolTransform config, where the configuration targets the already namespace name, API verbose name, and maps it to the final name, short. The transformation order is critical here. Since provider-level transforms execute sequentially, the namespace prefixing happens first, making the namespace names visible to subsequent transforms. This allows the ToolTransform to operate on the intermediate namespace names rather than the original names. The flow verbose name, API verbose name, short shows how each transform builds upon the previous one, with the final client-facing name being a product of both transformations. This pattern is particularly useful when you need to maintain clean, client-friendly names while preserving internal naming conventions. The namespace provides isolation between different service modules, while the targeted renaming allows for API-specific naming conventions. The trade-off is that you must account for the transformation order when configuring tool names, as the ToolTransform must reference the namespace names, not the original ones. This approach gives you fine-grained control over tool presentation without modifying the underlying provider's component names. Let's break it down. From FastMCP server providers, import FastMCP provider. Imports the FastMCP provider class from the FastMCP server providers module, which provides the base functionality for creating component providers in FastMCP 3. This class enables the creation of providers that can supply tools, resources, and prompts to FastMCP servers. From FastMCP server transforms, import namespace, ToolTransform. Imports namespace and ToolTransform classes from the FastMCP server transforms module. These classes enable component name prefixing to prevent naming conflicts and tool schema modifications, respectively. From FastMCP tools ToolTransform, import tool, transform config. Imports the ToolTransform config class from the FastMCP tools ToolTransform module, which provides configuration options for modifying tool schemas in FastMCP. Provider equals FastMCP provider server. Creates a FastMCP provider instance bound to the specified server, establishing a component source that will make tools, resources, and prompts available to clients through this server. The provider will handle discovery and delegation of components when clients query or invoke them.
Provider, add transform namespace API, hash applied first.
Adds a namespace transform to the provider that prefixes all component names with API. This transform will be applied first in the transform chain, modifying component names before any other transforms process them. Tools and prompts will receive an _separated prefix, while resources and templates will get a path segment prefix in their URIs.
Provider add transform ToolTransform hash, sees namespace names. API verbose name, ToolTransform config name equals short.
Adds a tool transform to the provider that modifies tool schemas by setting the verbose name configuration to use the short naming style. This transform will process tools from this provider, applying the specified naming convention before they're exposed to clients. The key takeaway here is how FastMCP3's Decorator pattern enables layered component transformations through sequential middleware-like filters. The pipeline starts with the namespace transform applying prefix-based isolation, creating scoped names like API verbose name that prevent collisions when composing multiple servers. This namespaced output then flows into the tool transform, which performs targeted schema modifications, in this case mapping API verbose name to the final client-friendly name, short. The critical insight is that transformation order matters. The tool transform must reference the already namespace names, not the originals. This two-stage approach gives you both isolation through namespacing and presentation control through targeted renaming, while maintaining clean separation between internal naming conventions and client-facing APIs. The trade-off is that you need to account for the transformation sequence when configuring tool names, but this gives you fine-grained control over component presentation without modifying the underlying provider's components.
The namespace plants verbose name in the garden, but the transform uproots it and hands back short like a stolen seed.